Alright, so we have covered one routing protocol, RIP. We are now starting EIGRP, Enhanced Interior Gateway Routing Protocol. Enhanced Interior Gateway Routing Protocol. You see, every routing protocol job is to advertise, distribute the networks to the other routers. The networks that are in this router plus the networks that are learned by this router both need to be advertised to the next router, so that those router will also know the route to reach these networks. For doing that, we need routing protocol. Routing protocol distributes route, not simply the route, they also distribute metric to reach them. The metric varies from one protocol to the other. Now, what is the metric of EIGRP? For RIP, we saw it's a hop count. The lowest hop count path is considered as the best path. Now, in EIGRP, what is the metric? The metric of EIGRP is like this. The bandwidth and the delay see, these two are considered, these two are taken. The delay that is happening to reach the destination from point A via path 1 and via path 2, if you have two paths, path 1 and path 2, to reach point B from A, the delay is compared. The path with the less bandwidth and the path with the more bandwidth and less delay is considered as the best path. We call this as composite metric. Composite. It's not one metric, no, it's combination. Composite metric. EIGRP provides composite metric. Bandwidth plus delay. Composite metric. Not just one bandwidth or just delay, it's collectively. There is an algorithm called diffusing update algorithm, which takes these two values and finds the composite metric for each destination on every path. The path with the lowest composite metric, lowest metric, is the best path. So, Enhanced Interior Gateway Routing Protocol, which is designed, proposed by Cisco, uses this dual algorithm. EIGRP is a Cisco proprietary protocol, Enhanced Interior Gateway Routing Protocol. This has got an older version also, which was IGRP. But IGRP is like RIP version 1, which is a classful version of Cisco proprietary protocol. The modification is done, enhancement is done. Even the number of bits to calculate the metric is increased from 24-bit to 32-bit. IGRP uses 24-bit, EIGRP uses 24-bit, 32-bit. EIGRP uses 32-bit for metric calculation. IGRP uses 24-bit. Older version uses less number of bits. Plus, this is classless protocol, EIGRP. IGRP is classful. So this two main difference you can see, very important difference, classless. EIGRP also follows the same composite metric, same algorithm. IGRP, EIGRP both use the same algorithm, but the main difference is the classful and classless. Now, diffusing update algorithm dual is doing two jobs here. Number one, finding the composite value. Number two, picking the low cost path, at the same time loop free path. Loop free path. Loop free path. Two things, loop free path and finding out the composite value for each path to reach destination, and pick the low cost path. So this function is taken care by dual. That's the reason why when a route is learned in the routing table via EIGRP, it will show you D, not E. See, for RIP it was showing R in the routing table. All the RIP learned routes are R. EIGRP learned routes are D. Diffusing update algorithm. D. So the character D in the routing table should tell you that this is EIGRP algorithm. EIGRP given routes. The one which chooses best path among all other paths. Best and loop free path. Now, as I said in the RIP topic, for every protocol there is a preference level, preference trust level, preference value called administrative distance. Administrative distance. The administrative distance of EIGRP is 110 is for OSPF. For EIGRP it is 90. Administrative distance of EIGRP is 90. See, we saw RIP, we saw administrative distance of RIP as 120. Now this is 90. Which one is preferred? EIGRP is preferred. Lower is preferred. Lower is preferred. When a router runs this two protocol, when both the protocols provide route to reach a destination, say for example 1.1.1.1, router will follow the instruction, the route given by EIGRP, not RIP. When two sources provide route, only one source can be honored and other one need to be discarded. Based on what? One will be honored and the other will be discarded based on the administrative distance. So the administrative distance matters only when you go with more than one routing protocol in the same network environment on same routers. Otherwise, this number is useless. Another thing is, the word administrative distance is Cisco way of calling this. The actual meaning is preference. So the other vendors, most of the vendors calls it as preference value. And the number 90 is only by Cisco. The other vendors don't have EIGRP, so you don't need to worry about the preference value of EIGRP with other vendors. No, they don't have this protocol. But for the RIP, you learned 120 in Cisco. It's not the same with Juniper. It's local to the vendor. That number, that's what I want to see. The administrative distance 120 that you learned for RIP is not same for any other vendors. It's not same for other vendors. It is not same at all. So that's one information, because in some interviews you will come across this. And if you are attending a Juniper interview, so you should not be stubborn saying that EIGRP is, RIP is 120. No, for Juniper it's a different number. So you should say like, this particular thing is vendor specific. Okay, now next is EIGRP is a classless routing protocol, as we already know. The older version of EIGRP is IGRP. It is no more actually seen in today's router. The classful version of Cisco protocol is no more. EIGRP has got two versions. EIGRP itself has got two versions. One is a numbered version, another one is named version. We'll see both here. Usually the named version I teach in CCNP, but I would like to show you here itself both later when we do the lab. Now, another thing that we should also know is these two are these two are not the only components of composite metric. Initially, there were 5 components. Component 1, K1, don't ask me, component spelling is C, no, why you are putting K? See, Cisco dual algorithm have it as K1, so I am calling it as K1. K1 is bandwidth. K2 is load. K3 is delay. K4 is reliability. K5 is MTU. So what do we see here is only these two. Sorry. Only this and this are considered. Considered. What I'm saying is this 5 will be seen in the algorithm, but those 3 that are not considered are multiplied by 0. If you multiply load, the value load into 0, what is the answer? You will get 0 only. Which means, though algorithm is processing it, it cannot use it because it is multiplied by 0. Load is also reliability and MTU. All these three are multiplied by 0 in this dual algorithm. So if someone argues saying no, EIGRP has got 5 metric, don't argue with them. You say yes, 5, but consider this only 2. That you need to very strongly say. Bandwidth and delay, or the 2. K1 and K3. Bandwidth and delay. The other 3 are not. Next. EIGRP is classless, as I said, so as a result there is no discontinuous problem. That's the word, discontinuous. What it means, when you have 10.1.0.0 172.16.0.0 10.2.0.0/16. You see, this is classless. And there may be another network, 10.3.0. or 10.0/24. Now you see, in the middle you have 172.16. If it is a classful protocol, there will be a discontinuous, means router 1 will not learn the roots of router 2. Router 2 won't learn the root of router 1 when you have a classful protocol. Because this is classless, this very clearly advertises saying, you see, I got only 10.1 network. I don't have any other 10 network. I just got only 10.1 with a mask. And this also will say, you see, I got 10.2 network only. And one more, 10.3.10 network only. Rest I don't have. These are the networks. So very clearly they advertise, as a result, R1 will learn these two. R2 will also learn that without any problem. If it is classful protocol, they don't support this variable length mask. What they simply do is they say, I got 10 network. This guy will also say, I got 10 network. So R1 will say, why should I learn which I already know? You give 10.000, I also have 10.000. Why should I learn? So both they don't learn each other. They don't learn each other. Classful protocols are like that. All right. So now we have discontinuous network support because it is classless. It supports VLSM. Next is this EIGRP. They don't send any periodic update. See, this is a very important point. In RIP, what we learned is, even when there is no change, it will advertise the routing table every 30 seconds. That is how we know they keep the routing table refreshed. Every 30 seconds, update will come from my neighbor. I'll take it, I'll process it, and I'll refresh my routing table. So every 30 seconds, the bandwidth is going to be consumed by this update. Processor is going to be used to process this update and to refresh the routing table, which is really not a good approach because it consumes bandwidth every 30 seconds. Every 30 seconds, it is going to consume CPU even when there is no change. This bandwidth utilization and CPU utilization, even when there is no change in the routing table, this bandwidth utilization and CPU utilization happens continuously. In EIGRP, you don't have such periodic update. EIGRP will send only triggered update and incremental update, triggered update and incremental update, triggered and incremental update. When will it send the triggered update? Incremental, meaning whenever the change occurs. Not every time, not periodically. Only when the change occurs, it will immediately, that is triggered. Immediately. That will immediately send the update. Triggered update. Immediate. Which is a very big advantage. Moreover, this EIGRP uses multicast address. To what? To send hello packets, updates, etc. Whereas RIP was using broadcast version 1, but version 2 was same like this. It uses multicast address. What is the multicast address RIP uses? 224.0.0.9. Version 2 RIP was using 224.0.0.9. The next number is EIGRP. What is the EIGRP's multicast address? 224.0.0.10. So the multicast address is used instead of broadcast. Very big advantage. Say broadcast and multicast, what is the difference? Broadcast is sending to everyone. The packet will say to address everyone. Is that good? No, it's not good. Then everyone will think that it belongs to them and they will open and they will drop it because they don't understand. But when you send to a multicast address 224.0.0.10, what does that mean? It means this update I am sending is for EIGRP only. That's the meaning of the 224.0.0.10. According to the standard, every routers know the packet with the destination address 224.0.0.10 is EIGRP. So, if only a router runs EIGRP, will accept this packet. So, because it's clearly said in the packet for EIGRP members only. 224.0.0.10 means what? For EIGRP members only. So they receive it, they open it. Others ignore it. Right. So the multicast address sends hello updates to, sorry, EIGRP sends using multicast address the hello and update. Very good advantage. Next. This EIGRP is designed not only for IP. IP is what? Layer 3. In layer 3 we have IP, we have IPv6, we have IPX, we have Apple Talk, etc. But you might have come across only these two, but these are also layer 3 protocol like IP. Now EIGRP has got an independent module, meaning there is one EIGRP designed for this, there's another EIGRP designed for this, there is another EIGRP. So you have an independent module. You can enable whichever the module that you want depending on your layer 3 protocol. Alright, independent from one another. So it's not same EIGRP for all these four. That's what I mean. There's a separate EIGRP for IP, IPX, Apple Talk, etc. Separate module. Next, very important point. When you talk about EIGRP, you must say about this particular point, otherwise, it will be incomplete. What is that? Unlike all other routing protocol, this supports unequal cost load balancing. Unequal cost load balancing. This supports unequal cost load balancing. Okay, so EIGRP, like other protocol, it supports equal cost. Like other protocol, it supports equal cost. But other protocols, they don't support unequal cost load balancing. Only EIGRP can do that. I repeat, every protocol supports, every routing protocol except BGP. Except BGP, every other routing protocol will support equal cost load balancing. What does that mean, equal cost load balancing? Say for example RIP. So there is a destination, let's say this alpha. To reach alpha, this is one path, this is another path, and this is another path. So I'll call this as path 1, path 2, path 3. RIP will say I'll choose the path with a low metric. So it picks P1 and P2 to distribute the load. So RIP, when packet comes to this alpha, it'll send one packet this way, one packet this way, again one packet this way. That's how it load balances. This is equal cost, right? Equal hop count. 1, 2, 3, 4. This is also 1, 2, 3, 4. Because the metric is same, it will use both the path. It ignores this path, the path 3, because it has got 5 hop. 1, 2, 3, 4, and 5. It ignores that path and uses the above two paths, equal cost. And this is there also in EIGRP. The composite metric, if it is same for the first two, it will use both. OSPF also can do that. But one thing EIGRP can additionally do is, it can even send some load on this path. But this supports unequal cost load balancing, but not enabled by default. It's not enabled by default. You have to enable this unequal cost load balancing. When you come to CCNP, you'll be learning these features. This is important points that we should always focus whenever someone talks to you about EIGRP, ask about EIGRP. Now, one more important point about EIGRP that we should know is EIGRP is an advanced distance vector protocol. But in CCNA level, I don't know why they are unnecessarily confused, and later they will correct you when you come to CCNP. In CCNA books and CCNA people, what they say, they will teach is, they will say EIGRP is a hybrid protocol, which is not true. Here they will teach us hybrid, and then when you come to CCNP, they will try to prove you that it is not hybrid, and then they will say this is an advanced distance vector protocol. An unnecessary conversation. So better learn correctly. EIGRP is an advanced distance vector protocol, not a hybrid protocol. Right? It's a waste of time knowing as a hybrid and then later correcting in CCNB level. That's unnecessary. Okay. So, what type of protocol is EIGRP? Advanced distance vector protocol. If someone is not agreeing with you, then simply say it's a hybrid protocol, but that is only for the beginner's knowledge. It is hybrid protocol. Truly, it is an advanced distance vector protocol. That's what you should say. You see, hybrid protocol, why they are saying like that? If you see EIGRP maintains some tables like a link state routing protocol, which we will be learning later after this, called OSPF. So it has got some sort of link state protocol outputs. Only output is like that. It's not for behind the screen functions are not like that. Just the output. All right, and then just the functions are like that, but it is not truly like a OSPF link state routing protocol. Right, so you should not call it as hybrid. They will compare with the RIP and OSPF and say, see, it has got some form of RIP, some form of OSPF, so they advocate it as hybrid. But that is not functionally correct. It has got no match to link state routing protocol. Right? Fine then. I'll stop.